So we're standing in our water reclamation plant where we reclaim our water, our processed water. Daniel is with me. He's working on a project here. He's going to describe that in a minute. Also with us, Hunter. You've met Hunter before. So one of the neat things for our interns, they get to work with people like Hunter. Great experience. Hunter's on our maintenance team, knows this place inside and out. And for an industrial engineer, mechanical.
Mechanical's my major, yeah.
Mechanical engineer, super cool because this is the practicality of all that stuff that we learn in books. And we come out here and here it is, like the real thing. So tell us about what you're working on and we'll walk through this a little bit, but what's the project?
Yeah, so we're here in water reclaim right now. When we produce concrete here, we make a lot of water that's very, very basic, has a super high pH, and we'd like to lower the pH, kind of neutralize it, the water that comes in here before we send it out into our storage tanks. And sometimes we reuse the water. And right now we use muriatic acid. You can see there's a big tank of it.
Yep.
And that tends to be very corrosive to like pipes and pumps and stuff. But it also lowers the pH pretty quickly. And what I'm working on is a system to use carbon dioxide instead of muriatic acid. It'll lower the pH slower, which means you can control the pH a little better. And there's no risk of over-acidifying, which we tend to do with the muriatic acid. We end up creating water with a pH kind of like 3 instead of more neutral. And so that's kind of what I'm working on here.
Yeah, so, right, I mean, for me,
yeah.
That's what Hunter's here too.
Yeah.
Smart cookie.
Yes.
Knows what he's talking about. And so our processed water, what makes it a high pH? What makes it so base? Why is that wastewater or processed water?
The aggregate that we used is a limestone base.
Okay.
Which limestone has a very base pH.
Yep.
And as we run water through that, it picks the pH and the base fluids up.
Got it. So what are we seeing here? We're seeing this water coming in from this white pipe. What is that?
Correct. That's the wastewater from both our Elomatic plant and our Tucker cleaning station, which is just above it.
Okay.
All of that washes down into a barn cleaner, which then drops down into essentially just a tank that has an auger that's moving in it to keep small particulates floating.
Okay.
The small particulates, when they reach the surface and they're floating, run through that pipe and into our tank down here.
Gotcha. So that processed water, that clear stream, actually is a high pH.
It is.
Yep.
And so what's going on inside this tank then?
So this tank has a giant propeller in it that just keeps the particulates floating in the water.
Yep.
And then the pump picks the water up, takes it up top to the press, which is a filter press. It filters out the particulate.
Okay.
And then the water comes back down to this large tank that we were talking about where it gets the pH treated.
Gotcha. So the gray water gets pumped up to the top
Filter press.
Up to the filter press.
Yep.
The filter press settles out all those very fine materials that you can't get by the settling tank.
Correct.
And then that water is into the steel metal tank. All right, so let's take a look at this thing. So Hunter and Daniel, we're looking at now the tank that has the processed water that's left after the fines have been squeezed out of it, right?
Correct.
And you're saying this water right now still has very high pH.
It's actually treated at this point.
Okay, so there's a stream of water coming out. Is that the water coming out of the filter press?
Correct, yep.
Okay, so basically there's very few fines at this point.
Yes, very few.
But that water that's touching the water in the tank, that's where it's being treated. So it's high pH, and then in the water in the tank is what?
Should be a fairly neutral pH. We try to keep it anywhere from 7 to 8 pH.
So how are we going to get CO2 into this tank? Daniel, you want to give that a shot?
So we're going to use aeration tubing. Most applications for aeration tubing are like in ponds where you want to have bubbles for like fish and stuff.
Okay.
But we're looking at that and bringing it in here. We're just going to connect it up with pipes. Most of it you just buy from McMaster Car. And so we're going to run it up the side here and then out, and then over here where this is where the acid is, that big tank. Instead there's going to be a CO2 tank there.
Okay, so we'll have compressed air.
Yep.
Instead of the muriatic acid.
Mm-hmm.
And that compressed air will be filtered out. You'll kind of open a valve. Is that what happens? And then that air, does it get pumped down into the bottom of the tank under the water?
Yeah.
So, I mean, how does it react with water? How does CO2 react with water? How does it?
So, I knew the chemistry a couple weeks ago when I was kind of diving right in. It makes carbonic acid. It's the same way that it works when you get like a fountain drink at a restaurant, where you have, it tastes acidic. It tastes a little bit sour, and that's because of the acid that gets made.
Compressed air, CO2 going in, and it's going to neutralize things. And then we get to reuse that water if we choose to,
Yes.
putting it in our tanks.
Yep.
That's great.